class, here we go. I had a request to work through the review page for Unit 2, Chapters 10 and 11 over Finance and Probability. I've got my review sheet here, I've got my calculator, and I also have my formula sheet. Remember that you are allowed to use your formula sheet on the test. Okay, so here we go. Number one says to find the missing quantity by using the simple interest formula. Well, I know that my simple interest formula is interest equals principal times rate times time. I'm solving for the thing that I don't know. On A, I don't know interest. On B, I don't know time. Okay, so on A, I'm going to use that simple interest formula to solve for interest. My principal is $1,150. My rate is 1.1%, so I rewrite that in decimal form. And then my time is 42 months. My rate is assumed to be an annual rate unless I'm told differently, and I'm not here. So I need to turn 42 months into years. I can either do that by doing 42 divided by 12, or I can reason through and say, you know what, 36 months is 3 years, and 42 minus 36 is 6. So 6 months is half a year. So 42 months is 3.5 years, or 3.5. Again, I could have also used that fraction as my time. So principal times rate times time. I input that into my calculator. And you guys can't see my calculator, I don't think. Well, there's a little bit better. And I get $44.28. You always round to the nearest penny. So $44.28. And that's the result that you had on the key. The key is already posted. I just didn't show you how to work them out. All right, for the next one, I plug into my formula. Same formula, interest equals principal times rate times time. But in this time, I have a different unknown. Okay, so I know my interest is $351. That should have a dollar sign there. Is equal to my principal of $2,600 times my rate of 0.045, because I changed that rate to a decimal, and time is what I'm solving for. So I'm going to do this multiplication first and then divide both sides by that value. When I multiply 2,600 times 0.045, I get 117. So I'm going to divide both sides by 117. And 351 divided by 117 gives me 3. Since it's time and we assume time is in years, we know that our interest was earned over 3 years. All right, exercises 2 and 3. Patty borrowed $1,640 from a bank for 18 months to buy a new office computer, and the simple interest rate charged is 3.15%. How much interest did Patty pay for use of the money? That's my simple interest formula again, because it even says simple interest. Finding interest. Interest equals that principal times the rate times the time. Where's my time? Time was 18 months. Remember, I don't put time in terms of months unless I'm told my rate is a monthly rate. So I need to turn 18 months into years. So 18 divided by 12, which is 1.5 years. When I multiply those three values together, I discovered that she is going to have to pay $77.49 in interest. If I plug it into my calculator, I've got 1640 times 0.0315. Sorry guys, I'm trying to get you to see and I don't think it's going to work. Times 1.5. Yeah, and it comes out nice and even. I don't even have to round. What's the amount of money she repays to the bank? Well, she has to pay back the amount of money she borrowed. So she has to pay back that $1640 plus interest. And $1640 plus that interest gives me a total of $1,717.49 that needs to be repaid. Okay, compound interest formula. Compound interest formula, if I go back and I look at my sheet, compound interest formula is right here, unless it's compounded continuously, and then I use this simplified formula. Neither of those has to be compounded continuously. Both A and B, compounded quarterly, N is 4, compounded monthly, N is going to be 12. My time is already in years, so that's good. My rate, I'm going to rewrite as a decimal. And I plug it into the correct formula. So my compound interest formula goes ahead, and when I get the result, it gives me the interest with the principal added in. P times 1 plus r over n to the nt power. So for A, my amount at the end is going to be that 7,500 times 1 plus 0.03 over 4, because that's how often I'm compounding the interest. To the nt power, well, 2 years, 4 times 2 is going to be an exponent of 8. When I plug that into my calculator and round it off to the nearest penny, I get a total of $7,961.99. That's the total amount she has to pay back. That's A. It asks you also to find the interest. Well, to figure out how much of that is interest, I subtract the principal. So I take that total of $7,961.99 and I subtract from it that principal, $7,500, and I discover that $461.99 is the amount of interest that was earned. Okay, let's do B. For B, I'm using the same formula. This time my principal is $2,500. My rate is 0.065, and I'm compounding it monthly over 3 years. So my exponent's going to be 36. When I plug that into my calculator, I find out that the total amount in the account at the end comes out to be $3,036.68. Well, how much of that total amount is interest? To figure that out, I take the $3,036.68 and I subtract $2,500 from it. The difference is the interest. Let me try one more time to see if you can follow me plugging things into my calculator. Maybe you can see it a little better than I think you can. Okay, so we're going to be doing B. I'm going to start on the inside because this is the way I like to do it. I'm going to start with the 0.065 divided by 12. I add 1 to that. Then I take that value and I raise it to the 36th power. And the last thing I do is multiply by the principal. And then I round that to the nearest penny. Okay, let's go back out and look at this previous balance credit card problem that we have here. It says Michael's credit card statement showed a balance due of $878.25 on March 23rd for the period ending on April 23rd. So that's the next month. So March 23rd statement, he had a balance of $878.25. $878.25. That is his previous balance when you get to April. That's the previous balance. So A says to determine the finance charge on March by using that previous balance method. Assume the interest rate is 1.4% per month. So that's just the finance charge on this much money. Finance charge, I'm going to use simple interest. So interest equals principal times rate times time. My principal is $878.25. My rate is 1.4% per month. It's a monthly rate. That's my key, that my time also has to be in terms of months. 0.014 is my rate. Well, how many months? Just 1 month, because our credit card statement comes every month. Since I have a monthly rate, my time is 1. When I multiply $878.25 times that interest rate, I get $12.30. Now, what I actually get, if you can see what I get, my light, there we go, is 12.2955, but I've got to round that to the nearest penny. The nearest penny is here. When I round that up, I have to also round here. So that comes out to be $12.30 as the finance charge. All right, determine the new account balance on April 23rd using this finance charge. So this is a new charge. We already owed $878.25. That is my previous balance, so that's a charge. And then we have another charge. We have this finance charge of $12.30. So I am going to combine all of these things. I'm going to add everything together except the payment. The payment gets subtracted out. So I start with my previous balance of $878.25. I add all the new charges, 1, 2, 3, 4 new charges, and the finance charge. So I add all of those things together. And then I subtract the $450 that was paid to get a credit card balance of $1,146.57. Okay, let's look at the next page and talk about mortgages. Oh dear, that is not the next page. Let me find the next page. I didn't come home prepared to work on this one. All right, here we go. Okay, building a house. The Loons decide to build a new house. The contractor quoted them a price of $144,500. The taxes would be $3,200 per year. Insurance would be $450 per year. Now, right away, it gives me a yearly amount for those two things. So I need to think about what is going to be the monthly amount for each of those two things. So I'm going to take my tax and I'm going to divide the $3,200 by 12. And that comes out to be $266, and if I round it, $67 per month. And then the insurance, I take that $450 and I also divide by 12, and I get the insurance is going to be $37.50 per month. Okay, they've applied for a loan. The bank wants 15% down, interest rate of 10.5%, 2 points paid up front. We've got an annual income. And we've got long-term debt of $220 for a car, $175 for furniture, $210 for a college loan. Okay, the bank will approve a loan where their adjusted gross income, 28% of their adjusted gross income is less than or equal to what's being asked. So let's work through our questions in order. What is the required down payment? Well, the down payment is going to be 15% of the price. So I take my price and I multiply by 0.15 and I get a down payment of $21,675. Well, if they're paying that down, they're not borrowing that much. So in order to figure out how much they want for their mortgage, how much they're asking to borrow, I need to subtract this from the $144,500. So I'm going to take that $144,500 and subtract the down payment. And I know that they are asking for a mortgage value, a mortgage amount of $122,825. That's how much they're asking to borrow. Points are calculated on the mortgage. So the total paid for the points, they want 2 points. That's 2%, so 0.02 times the mortgage amount. When I multiply that, 2% of the amount that I need from the mortgage, I get a value of $2,456.50 that they need to pay up front for points. So I've got my down payment and I've got my points. Next, I need to determine 28% of their adjusted monthly income. Well, adjusted monthly income, first I need to get the monthly income. Okay, monthly income. Their yearly income is $86,500. So I'm going to do $86,500 divided by 12. And I find out that their monthly income is $7,208.33. I need to subtract from that the long-term debt payments. And that's going to give me their adjusted monthly income. Well, long-term debt payments. The car, the furniture, the college loan. So I subtract those three amounts from their adjusted monthly income. So subtract $220 for the car, $175 for the furniture, $210 for the college loan. And their adjusted monthly income is $6,603.33. To start looking to see how much the bank will loan them, I need to take 28% of that because that's the max that they will loan. So I'm going to multiply that adjusted monthly income times 0.28. And I get a value of $1,848.93. If they're going to get their loan, the total monthly payment, including tax and insurance, needs to be less than that amount. All right, next step. I need to figure out the monthly payment for principal and interest. Sorry, I've got desk issues. I need to determine the monthly payment of principal and interest for the 30-year loan. Well, I need to pull out my payment formula. So I go look at my formula sheet. There's my payment formula. That's that big convoluted formula that we don't have to memorize because you're going to be able to use your formula sheet. All right, my payment formula for this house, principal is the amount of the mortgage, the amount I need to borrow. So $122,825 times R over N. The interest rate that they're asking for, that the bank is offering, is 10.5%. So not 0.0. Let's do that again. 0.105, because 10.5% would be 0.105. Over N, we're making monthly payments, so N is 12. All over, and in my denominator, I get 1 minus 1 plus that 0.105 over 12, raised to the negative NT, and they're going to take out, how long? A 30-year loan. There we go, 30-year loan. So 12 times 30 gives me an exponent of negative 360. That is what I have to work through and input into my calculator. Hopefully you guys have done that enough times that you know that order. And I get out a principal and interest payment of $1,123.53 when I walk through those steps. That's the answer to 15. Number 16 says to determine their total monthly payment, including that principal and interest, this that I just found, plus insurance and tax, because that's what the bank looks like. So to answer number 16, I'm going to take this and I'm going to add that monthly tax and monthly insurance payment. And I get a total monthly payment of $1,427.70. So that goes right here, $1,427.70. Their P&I payment was $1,123.53. That's what we got using the formula. We added in tax and insurance, and we get $1,427.70. So do they meet the requirements? Do they get the mortgage? Yes, they do, because they compare their 28% of their adjusted monthly income, this $1,848.93, to this total monthly payment, and the payment is less than that. So yes, they get to have the mortgage. All right, number 18 has two final questions on it. Determine the total cost of the house, including homeowners insurance, excluding homeowners insurance and taxes after 30 years. So we're not going to use homeowners insurance and taxes, which means we're not using this $1,400 amount. We're using the $1,123.53. They're going to take that payment, and we're going to do A right now. We're going to take that payment, $1,123.53, they're making payments for 30 years. So they're going to make 360 of those payments. The total cost of the house is going to include their down payment, which if you look up there, their down payment was $21,675. $21,675 down, plus the amount they paid on points, $2,456.50. So when I multiply the payment times 360, so I take that $1,123.53 times 360, $1,123.53 times 360, and then I add to that the down payment, and I add to that also the cost of the points. I get that the house is going to cost them a total, oh, I did something wrong there. Let me go back. So I had $1,123.53 times 360. All right, there we go. So 1123, back to where I was. 1123.53 times 360, and then I add my down payment, $21,675, and then I add points, 2,456.5. What did I do wrong? I'm having a bad day with my calculator. I can't see what I'm doing. Times 360 plus 21,675 down. So when I add the total of the payments to the down payment, I get the $426,145.80. And then I add to that $2,456.50. There we go. That's what I was after. $428,602.30. That is their total cost of the house. Sorry about the calculator issues. Okay. And then B, this final one. How much of that is interest, including points? Well, okay. So let's go back and let's look at this number. The total of the principal and interest payments, $1,123.53 times 360. So $1,123.53 times 360 is my total of the P&I. I'm going to subtract from that the amount of the principal, the amount that I borrowed. So I take that and I subtract the amount of the mortgage. The amount of the mortgage was $122,825. So I'm down to $281. $645.80, but notice it says including points. So I need to take that total interest from the principal and interest payments, and I need to add the amount that I paid for points. Well, I paid $2,456.50 for points. So that's the total interest paid for the house. $248,102.30. Okay. We've got one more page to go through. We're going to switch to the chapter 11, the probability and statistics stuff. Now remember that this written review is not exhaustive. You need to make sure that you do the online practice test as well so that you have reviewed everything necessary to be prepared for the upcoming exam. Okay, donuts. Of the last 25 people who purchased a donut at Dunkin' Donuts, 11 got a glazed donut. What is the empirical probability that the next person who gets a donut will also get a glazed donut? Well, empirical probability is the same thing as experimental probability. It's based on the results of an experiment or a trial. They did a trial, and out of 25 people, 11 bought glazed. So that is my empirical probability. I'm going to write it as a fraction in lowest terms. If I'm told to change it to a decimal and round it to a certain number of decimal places, I will, but otherwise I'm going to answer with a fraction in lowest terms. In exercises 2, 3, and 4, each of the numbers 1 through 9 is written on a sheet of paper, and those 9 slips of paper are put in a hat. If one sheet of paper is selected at random from the hat, determine the probability that the number selected on it is. Well, we've got numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers in a hat. A says, what's the probability that if I draw a number at random, it's going to be greater than 5? Well, what are my values that are greater than 5? these values are greater than 5. 4 of them are. 4 of the 9 values are greater than 5. So that's the answer to number 2. What's the probability that will be odd? Well, 1, 3, 5, 7, and 9 are odd numbers. That's 1, 2, 3, 4, 5. 5 of the 9 numbers are odd numbers. What is the probability that if I draw a number at random, it will be even or less than 4? Well, my even numbers are 2, 4, 6, and 8. Are there any other numbers that are less than 4? Well, yeah, 1 and 3. That means that 1, 2, 3, 4, 5, 6 of my values are either even or less than 4 or both. I'm not going to leave that answer as 6/9 because it's not in lowest terms. I'm going to reduce it by the common factor of 3 and get 2/3. Okay, one card is selected at random. Now make sure that you know how many cards are in the standard deck and that you know the suits and things like that. We've been asked questions about those card questions several times. Make sure you're familiar with the deck of cards. One card is selected at random from a standard deck of 52 cards. Determine the probability that the card selected is red or a picture card. Well, what are my picture cards? My picture cards are Jack, Queen, and King. My red cards, half the deck is red, half the deck is black, right? So I'm trying to think if I would count ace as a picture card. Let's see how this, we're not going to count ace as a picture card. Okay, so out of my 52 cards, 26 of them are red. And 3 in each suit are picture cards. So there are 4 suits. That means that there are a total of 3 times 4, 12 picture cards. But half of those picture cards are already over here in these red cards. So I'm going to take those 12 picture cards. I'm going to subtract the ones that are already over here in these red cards. So that's a total of 6 more cards that are picture cards. So 26 red plus 6 additional picture cards is 32 out of 52. Those are both even numbers. So let's reduce it by 2. If we reduce it by 2, we get 16 out of 26. Still even numbers. We can reduce it by 2 again. We get 8 out of 13. That's my probability. All right, passwords. A personal password for an internet brokerage account consists of an uppercase letter followed by 2 digits followed by 2 uppercase letters. So 1, 2, 3, 4, 5 items in this password. Uppercase letter, 2 digits, 2 uppercase letters. Determine the number of personal codes possible if the first digit cannot be 0 and repetition is permitted. Now, order matters. I have different sets of items. If I have different sets, then I'm using my fundamental counting principle and I'm just multiplying together. So first is an uppercase letter. We've got 26 letters, 26 uppercase letters in the alphabet. Then I have 2 digits. It says the first digit cannot be 0, so that means there's only 9 options for that first digit, but there's 10 options for the second, because repetition is permitted, and it doesn't say anything about me limiting what digits for that second digit spot. Then the last 2 are going to be uppercase letters again. So I need to multiply those things together. Basically, I've got 26 cubed times 90, because 9 times 10 is 90. And you should get a total, not dollars, you should get a total of 1,581,840 possible passwords based on those requirements.